This is 8.6 day 1, simplifying radical expressions. Earlier this chapter we talked about reducing radicals that had square roots, which are index of 2. Now we're going to look at some that have indexes of 3 or 4. Here's just a review of an example that we did where we take the square root of 24. And how we break that down is we think about what type of multipliers multiply to 24 that we can maybe find a perfect. So if I reduce 24 by 4 times 6, and then I notice that the square root of 4 is 2. So our final answer then would be 2 square roots of 6. This next example now has a different index. Example B is the cubed root of 5 cubed. So now we're looking at problems that have to have a group of 3 in order for it to reduce down. So the third root of 5 cubed, or we also say the cubed root of 5 cubed, your final answer then would just be 5. Next example now is not a perfect cube. So we look for different ways to break down 24. 24 can be rewritten as 8 times 3. Then I can break down 8 as 2 times 2 times 2, or 2 cubed. Now what will reduce out is this cubed root of 2 cubed. So that's going to go out in front. And then I have my leftover still of this 3. So then my final answer then is 2 cubed root of 3. Next example, we're back to a square root. Remember, if there isn't a number in the index, then you have to assume that it is a square root. So now we're looking for pairs. So let's break down 75. 75 can be written as 25 times 3. And then x cubed can be written as x squared and x. So then what can reduce out is this 25 and this x squared. 25 square root of 25 is 5. Square root of x squared is x. So then what I'm left with, my leftovers, is this 3 and x. So my final answer then is 5x square root of 3x. But on to question E. Now we're back to an index of 3. So we're looking for multipliers that have 3 of them together. So let's break down 128. 128 can be rewritten as 64 times 2. And then x, y, cubed, y. I originally had 4 y's, but remember my index is 3, so I'm looking for groups of 3. Now, 64, you can rewrite 64 as 4 times 4 times 4. And then I'm just going to group the y cubed next to the 4 cubed. And then I have left the 2, the x, and the y. Now what's going to go out in front are groups of 3's. So cubed root of 4 cubed is 4. Cubed root of y cubed is y. Then what's left are the things that are not in groups of 3. So these 3 things are my leftovers, 2, x, and y. Next example, cube root. So we want to break down 108. What are some multipliers of 108? And if you don't know, just start with your calculator. Do the opposite, divide by 108. So 108 divided by 2 is 54. Or 108 divided by 3 is 36. Or 108 divided by 4 is 26. Look for different multipliers. So I'm just going to do 2. So 2 times 54 is 108. And then I'm going to break down that x to the 4th as x cubed and x. And I'm going to break down the y to the 6th as y cubed and y cubed. Now we can reduce again that 54. 54 can be broken down again into 2 and 27. So 2, and then I have that 2 and 27 combines together to give us 54. X cubed, x, y cubed, y cubed. Now let's see if we can go farther with that 27. 27 can be rewritten as 9 and 3. Or 3 times 3 times 3. Now I have 3 cubed. And then I have 2 times 2. And then I have x cubed, x, y cubed, y cubed. So what's going to go out in front is anything that is a cubed. So this 3 cubed, cubed root of 3 cubed is 3, cubed root of x cubed is x, cubed root of y cubed is y, cubed root of y cubed is y, and now what I'm left with is these 2's and this x. So then my final answer is 3x y squared, and then the cubed root of 2 times 2, which is 4, and then x. Let's go down to question G. Question G now has an index of 4. So now we're looking for groups of 4. So if we rewrite 81, 81 can be changed into 9 times 9. And then x to the 12th can be broken down into x to the 4th, x to the 4th, and x to the 4th. We will still want to reduce those 9s, so those can be 3 and 3 and 3 and 3, because 3 times 3 is 9. And then we have the same x to the 4th, x to the 4th, x to the 4th. So now what's going to go out in front is anything that's in groups of 4. So there's 4 of them. So what goes out in front is a 3. 4th root of x to the 4th is an x. 4th root of x to the 4th is an x. 4th root of x to the 4th is an x. Nothing is left underneath, so our final answer then is 3x to the 3rd. All right. This is just a little piece from your textbook talking about the nth root, depending on what the index is. So if you have an odd index, you could have one real root. So like cubed root of 8 would be 2. And it kind of goes through, you can just kind of read through that. It's also in your textbook. So now we're going to focus on multiplication. I'll save this for the next video.